The title of today's lesson sounds really fancy, but in reality, it's pretty straightforward now that we know how to multiply and add radicals. If I say 3 plus root 5 squared, we all know by now that that means 3 plus root 5 times 3 plus root 5. And as I said at the beginning of this unit, radicals behave very much like variables, so to multiply these together, we FOIL, just like we did before. First is 3 times 3, or 9. Outer is 3 root 5. Inner is 3 root 5. And last is root 5 times root 5, I hope you've got that down by now, is the constant 5. Then we just have to combine like terms. 9 plus 5 is 14, and 3 root 5 plus 3 root 5 is 6 root 5. When you have squares, they behave something like that. Here's a little bit harder one, 2 root 3, because they have coefficients, minus 5 root 7 squared, which means I'm going to say 2 root 3 minus 5 root 7. So the only reason this is harder is just the computation is a little bit harder. 2 root 3 times 2 root 3, we do this just like we were doing variables. We multiply the coefficients, that gives us 4, and then we multiply the radicals, and root 3 times root 3, as you all know, is 3. That's first. Outer is minus 5 times 2 is 10. Root 3 times root 7 is root 21. Inner is the same thing, negative 10 root 21. And last is negative 5 times negative 5 is 25, and root 7 times root 7 is 7. So when I combine all of the constants together, I find out this number is 12, and this number is 175, and 12 plus 175 is 187, and this is minus 20 root 21. It's just like combining like terms. We add the coefficients, negative 10 and negative 10, and the radicals at this point, in this situation, stay the same. It's exactly the same as we've done in the past. What's interesting, though, is that if I say 6 plus root 11 times 6 minus root 11, an interesting thing happens. When I do first, I get 36. When I do outer, just as we know, this is like the factoring pattern for a difference of squares. 6 times negative root 11 gives negative 6 root 11. 6 times positive root 11 gives positive 6 root 11. And last, positive root 11 times negative root 11 is negative 11. You can see that these are going to cancel out because they're the same thing with different signs. So my final answer is simply 36 minus 11, which is 25. Notice, all of the radicals went away. I multiplied these two things together, and I ended up with a rational number. We use that fact, rationalizing the denominators of fractions that have binomials. So in class today, we talked about, for a while, about how could you get rid of this radical. And in the end, we used that fact that we just saw. If I multiply by the same thing, only with a different sign, 5 plus 2 root 7, I'm going to get a rational number. If I do it to the bottom, I have to do it to the top. So again, the math here is a little bit more complicated. We do the distributive property. 3 times 5 is 15. 3 times 2 root 7 is 6 root 7. And then in the bottom, when I do first, I have 25. outer and inner are going to cancel out because they would be 10 root 5 and 10 root 7 and negative 10 root 7. And last gives me minus 2 times 2 is 4, and root 7 times root 7 is 7, so it's 25 minus 28, or negative 3. And we put that right here. Generally, we like to, well, actually, that doesn't matter. Just like if this were a variable expression, if I had, say, 15 plus 6a divided by negative 3, I can reduce this because everything is divisible by the denominator. In other words, I could say 15 divided by negative 3 plus 6a divided by negative 3. And that would give me negative 5 plus negative 2a. We're going to do the same thing here. As I said, radicals behave like variables, so that gives us negative 5 minus 2 root 7. All expressions need to be fully simplified, including the idea of reducing fractions that you could have. Let's just do one more example of these because it's part of what we have to do. Let's do the last example. 6 minus 2 root 3 over 3 root 2 plus 3. Actually, I take it back. That one seems too complicated. Okay, well, my eraser isn't working, so I'm just going to put an X through that one. Let's do one that seems a little bit easier, because that seems unnecessarily complicated. 5 over 3 root 7 minus 5. Okay, if I need to rationalize a binomial denominator, I multiply it by the same thing, only with a different sign, so just like with the difference of squares, that pattern. When I do the top, I get 15 root 7 plus 25. When I do the bottom, 3 root 7 times 3 root 7 is 9 times 7, or 63. The outer and the inner cancel out, and last gives me minus 25. So 63 minus 25 is 38. And I check to make sure that these three numbers don't all have a common factor, and they don't. So I'm done.